So we're now at the point where we've got a reasonably working syringe-controlled arm, and it can move through a range of motion right here. And what we're going to be curious about is, does it have the range of motion that we need in order to scoop the dirt out of the pit and deposit it into the dump truck? And can we optimize that range of motion by playing around with some of the parameters so that our excavator can scoop as much dirt as possible? And to do that, we're going to have to add in some dimensions for the pit. Now, like everything else, I like to start off any of my new drawings or any of my new designs with a little bit of a sketch. And so in order to get this sketch, I went back to a PowerPoint presentation that's a little bit earlier in this channel, where we went through what the challenge is actually going to be about and how it's all going to come together. And your excavator is going to be here in the excavator zone reaching into the pit. The pit's going to be filled up a little bit higher, and you're going to be depositing the dirt, those plastic pellets, into the dump truck. And you're going to try to move as much as possible. And towards the end of that presentation, you've got some photographs with the measurements of the pit and some just basically sizes and scales so that you know how big to make things. And so I was able to take some of that information right here, and I printed out a quarter scale drawing of the arm that I've got together right now. And then I was able to take the dimensions from the drawing and come in here and sketch in how this is going to go. And right now, this is actually looking kind of okay to me. Looks like we might want to get this down a bit deeper, so we might have to play around with some of those parameters in there. And we also need to be able to get it up 9 centimeters. Again, this is at a scale of 4:1, or 1:4, I should say. We need to get it up 9 centimeters on this side so that we can, or over on this side here, it doesn't matter because you can put the dump truck on the sides of the pit. We just want to make sure that when we do a scoop that we can lift things up and out of the way. And so, like I say, always start off with a drawing of what you're going to create so that you have an idea of what it's going to be when it comes time to go ahead and make that part. And then we're also going to take a look at ways where you can actuate some of these syringes individually rather than doing this whole inverse kinematics thing where I have to just keep pulling on it and hoping that it bends the way I want it to go. So hopefully you've got this kind of movement right now and things are limiting themselves and staying within their range. And now we'll take a look at saying, do we have enough range? Now, keep in mind, our analysis is also going to be subject to our last discussion on the impacts of what happens when you lower that boom. And you can see right out here that we've got a nice big lever arm right up here. So we should be able to get lots of torque to twist that up and down. But you have to watch out as that boom comes down lower and lower and lower in here. Sometimes your lever arm gets shorter. And if you come too far and your boom's down on this side, then you've gone over center and locked it in place. So we are going to have to play around with some of our parameters to make sure that we don't end up locking our boom in the down position, because yes, we could drag it back up in Fusion 360, but that's not going to happen in the real world. Okay, so I think the simplest way for us to go about doing this is going to be to create a new design. So just come up here to new design, make sure that you've got your syringe excavator folder opened up right here. If that's taking up too much space on your screen, you can click on the little data panel right there and poof, you've got the whole thing. If you need that back again to see that, just click on show data panel, and we're just going to come in here and tell it we want a new design. There we go. And on our new design, we're just going to create a sketch right here, and we're going to pick any old plane. That one should do. And now we're just going to sketch the profile of the pit that we're coming into. Okay, and so let's come along right here, and we may as well just start at the origin right here. And according to my measurements, we're about, well, we'll be 11 centimeters along here, so that'll be 110 millimeters. So I'm zooming out a bit, and we'll dimension it later. Okay, then it's going to come down at an angle in here, and it's going to come down about 19 centimeters deep. We'll dimension that later. Then we'll come over this way horizontally. We'll come back up to this level, and then we'll come some distance out this way. And then we'll just say that's all good for right now. Okay, let's come in here and add some dimensions to this. And from the dimensions shown in that PowerPoint with all the pictures of our setup, you'll notice that from the edge of the plywood to the beginning of the pit, it is about 110 millimeters, okay, 11 centimeters. Then from the bottom right here, right up to there, is 190 millimeters or 19 centimeters. And from this point right here to this point right here, and you can see how we can get either an aligned dimension. I want the horizontal dimension, so I have to bring it down here to get that. That is going to be about 30 millimeters because it's 3 centimeters. Dimension across the top from right here to right here is going to be 33 centimeters or 330 millimeters. And the dimension from right here down to right here, again, I have to pull it downwards, is also going to be 30 millimeters. That brings that in right there. And over on this side, it's going to be a little bit longer, but I'll tell you what, if I make it 11 centimeters on that side as well, then everything's fairly much parallel. It doesn't matter which way it comes out when I put it in. Now, this is just going to be a profile. We could create a 3D model of the entire thing, and we will do that later on when we've got our structure all put together. But for right now, I'm just going to keep it as a two-dimensional model so we can see that excavator bucket reaching right down into here and seeing if our bucket is going to have the range and the stroke that we need to be able to get in there without jamming up any of the syringes by going over center or anything like that up over here. All right, now the quick way to turn this into a little bit of a wall is that we can come to create and there is it modify where our offset is. Offset, exactly. There we go. And let's take that curve and we want to offset it to this side. And let's offset it by, I believe that is 1/2 inch plywood at the top. Let's offset it by 12 millimeters to get our 1/2 inch plywood. Okay, and now you can see that we've got a profile on here. Now, obviously, this is not the true profile. There's some little perturbations in here. This is close enough that we're going to be able to approve our design and get the optimal dimensions for it. How it comes in the final driving is going to be up to you. Now, to make this a profile that we can extrude, we need to add line at the end right there. And we need to add a line at the end right there. And you can see that shifts into blue right there so that we've got a profile that we can work with. Okay, the next thing that I'm going to add right in here is coming off from this side is I'm going to put a little bit of a base for, this will be the table, the excavator zone that our excavator is going to rest on, and the excavator is going to come in here and its base is going to butt right up against here. This is the wall of the construction zone according to that PowerPoint that we were looking at. So we can come in here and we can just take a rectangle right here and draw it out like that. This comes some dimension back this way. Put that in right there, and it goes blue because it is a rectangle. And we probably don't need to do much else. That's going to give us a surface right there. But what we can do is we can take a collinear constraint and say that this line right here should be collinear with that line right there. Over constrained, it already figured that out. So when I say over constrained, that was the error that flashed up right there. And it's saying you don't have to tell me that's collinear with that one because that point is coincident to that point, and we've got horizontal constraints on both of them, so therefore it has to be collinear. Perfect. We now have a profile that we can extrude. Let's finish that sketch and let's do an extrude. Let's take that surface and let's just extrude that by, let's come out 10 centimeters, 100 millimeters. It really doesn't matter because we're just using this as a profile right now so that we can see when we put our excavator right here, how deep it's going to be able to reach down into the pit, and we're going to be able to test its range of movements. So now that we've got the general profile set up, let's just put one additional reference into here. We do need to lift our bucket 9 centimeters above the platform right here in order to get it into the dump truck. That shouldn't be a problem, but we want to make sure that we've got all of our critical dimensions in here. So let's just add a quick little sketch right onto this surface right here. And I'll just take a little rectangle, doesn't have to be very much, and just tuck it in this corner right here. And let's just make it, actually it doesn't matter how big it is really. Let's dimension that in there. And let's just make it a little pole, 1 centimeter by 1 centimeter. And we'll finish that. And then what we'll do is we'll just extrude this 90 millimeters. Now, like I say, this is just a little bit of a mock-up so that we have a measuring stick right in here. So when we go to test our arm, we can just sort of eyeball that and make sure that we're getting higher across there. If we wanted to, we could actually build a little bar in here. Heck, we could build the dump truck right in here. It doesn't really matter. This is right now just being used as a visual reference for us to make sure that our range of motion is going to be able to come down in here and scrape everything up. And let's go ahead and close this design, the profile of pit, and let's save that. And we can actually close this design because now we're going to come back to our arm end linkage and open that up. And you'll notice different numbers down here. So this is one of the nice things about Fusion. If you ever screw up on your design, you can just click on here and say, well, yesterday I was doing pretty good. So you can go back multiple versions into your design and it saves it for you at every step so that in the event that you mess up, it's there for you and you can go back and fix things up. Okay, so that was our arm end linkage that we were playing around with at the beginning of this video and how it all comes together. And what we're going to do now is we're going to drag profile of pit into here. Okay, and it just becomes another component in our diagram. We can move it down a little bit so that we can see things more easily. Doesn't really matter where we put it because we're going to now use that as our reference and we're going to ground our arm to it. So let's just say, okay, we've got it in there somewhere. I'm not too worried about where it is. I'm going to click on this little button right here, hide the data panel, so I've got the full screen to work on. And now before we join anything in here, we have to think about the fact that for all of our testing so far, this base has been grounded. And you can tell it's grounded because when you come and look at your design, you can see that the base has that little pin next to it. Okay, that means it's grounded. We want to move the base to match up with this design right here. So in order to do that, our profile of pit is going to become the new grounded thing. We are going to unground the base. And now there's no longer a little pin right next to base. We're going to come down to profile of pit, right click on that and ground that so that you get the little pin right in there. And now in our overall context, this base can't move around at all. Well, anytime you see the screen blip like that, that is a sign that there's been a disruption in the timeline and I've come back to fix a problem that I ran into. And in the past videos, some of those have been hidden over. And I just thought it was important to mention that I know as you're following along the videos, you'll sometimes miss a critical step and you'll have to go back in the video and you'll have to hit undo a bunch of times. And then it won't be immediately obvious why you had to go back and undo something. And believe me, I know where the undo key is because I've had to come back. I was about half an hour down the road into this explaining how something was going to work. And although I could have fixed it at that point, it would have interrupted the time flow for you and it would have created more confusion than necessary. So I hit undo a whole bunch of times and I came back to here and I'll show you how to do it right the first time so that we don't run into the problems that I ran into a little bit later on. Okay, so now we've got this grounded. Okay, so our profile of the pit is grounded, and we need to attach the arm to it. We're going to attach the base of the arm onto this platform right in here. And we need to attach that in such a way that this stays put and doesn't flip around when we go changing our parameters. And there's a number of different ways to join it. And we want to make sure that we get it in a way that's going to work while still allowing the arm to be nice and flexible. So what we're going to do is we're going to create a joint and we can just click continue. I'm not too worried about the fact that the components have been moved in there. This puts it back to the way it was last time we made a joint. And I'm going to select this face right in here. And I'm not clicking right on that center node, just the entire face right there can be selected. Okay, and you can pick a corner. I'm going to pick that corner of that face right there. And so that is our joint right there. And we've got the face selected right here. And what we want to do is we want to join that together to this face right here. And we want to use, so pick that face and it says where on that face do you want it to join together. We're going to click right there. Now you'll notice that spun everything around. You may have to hit the flip button. And if you've got it right, the lower of the two holes right here is going to be in the front, about like so. Okay, and we have all sorts of abilities to tweak and adjust this. If we want, we can move it in from the edge a centimeter so that we can see our profile really clearly right there. And so there we go. Click OK right on there, and then the rest of our syringe comes in to match. And now we should be able to take a look at it from an orthographic point of view and reach out and dig down. Oh, that's not going very deep. We'd really like that bucket to be able to reach all the way down or pretty close to all the way down to the bottom. So this is why we're still playing with the parameters and we haven't come through to build our final arm yet, is we're really at a prototyping stage and we're trying to figure out this range of movement using the syringes that we've got right in here. And one way we can bring this down a little bit lower, you can see that this syringe is already retracted all the way. If we drop this measurement down a little bit right in here, in fact, we could drop this one down too, and we can bring them both down a little bit. But let's take a look at this one right in here. And to change that, we come into our parameters, and that parameter right there is in the base, and we know that that one is the second hole. Y is our vertical dimensions. And let's drop that down to 50 millimeters down from the top. And you can see that dropped right down in there. And let's just say OK. And let's check our range of movements. And now that comes almost all the way down to the bottom. And yet it still comes up high enough. In fact, we've probably got enough distance in here that we could bring this down even a bit lower. And as we bring that down, what's also nice is when we're in our lowest, most stretched out position over here, when our torque about this movement right in here is going to be at its highest, we're actually increasing the lever arm distance between that line and that line. We're increasing that perpendicular distance between the two of them so that we get more push to lift that back up, which is going to be important because there is going to be a lot of torque when this is a full bucket right in here and we go to try to lift that back up. So let's come in here and let's modify our parameters a little bit more. And I'm going to take that down to actually 70. I got to click on it right there. 70, and this one, I think I'm going to bring it down because we've got lots of additional height. Let's bring that down to 35 right there so that that's recessed down into our base here. We're basically just lowering the effective height of the base. And now we can come down, and at this end, we're actually going all the way through the middle. We've still got plenty of up availability on there. And when we reach out this way, we'd like it to be a little bit longer. We'll take a look at that in just a moment. But that is coming down quite low. And what's nice is that we're not going over center with that syringe. That big 30 milliliter syringe has a lot of lifting to do. And I think this is a pretty good range of movement for our specific design parameters. Okay, if we needed to reach up higher, obviously we'd redesign that arm a little bit. Other things you can play with in here, you can play with the location of our connection right up here. We might come along and play with that in a bit. You can play with the length of this right in here by making this go a little bit longer and have it come out here. You've got a whole series of parameters, and you can play around with them. Let's see if we can make this stretch out a little bit further right in here. So let's come in here and take a look at our parameters. Now that was in our arm right here, and those were the X dimensions along our arm, and X3 and X4 were the long ones that had to reach out a long distance. And let's set this up to 250, give ourselves a couple extra centimeters, and we can set this one up to 230, we'll match that. And now you can see that arm, let's just click OK, reaches out a little bit further, comes down lower than we need it to, in fact, lifts up really good, still stretches out right here. Now the downside of doing too much of that is that as this distance in here gets longer, the torque of required to lift this back up gets higher. Okay, we've still got a pretty good range of movement. In fact, we've got more range of movement possibly than we need right on there. And we might be able to adjust that in order to increase the torque of that arm. So if I take a look right here, this is how we set this part up. Maybe if we increase that height right there, that will increase the lever arm that's acting on this arm. So let's modify and change parameters, and let's change the height of this part right in here. That was Y, the vertical height for hole number 4 coming off the bottom when we made that sketch. And let's give it an extra centimeter, make that a bit taller. And again, let's come down here and see how now there, that tucks all the way back in. That lifts up really nicely, and you can see that we're getting a longer distance between here and here, meaning that this has a bigger lever arm to counteract the extended lever arm that we put out here. We'll still probably need some kind of elastic or that to help pull that back in. And if our bucket was wide open right down here, the linkage is a little bit more complex to model, so I'm going to have to play around with that, and I'll show you some tools where we can play with them on a joint by joint basis in a bit. Right now you can get in here and you can drive certain joints around to see what that bucket looks like when it's open. But that's coming up here, and it looks like right out here we should be able to turn that and do a dump, come in, dig, come in, scrape up along that wall, and that seems to be working with a fairly nice set of range of motion in there. I might even try increasing that height by just a little bit more and seeing what happens right there. So modify, change our parameters, and that was our Y4. Let's give it 1 more centimeter. Okay, longer lever arm right here. So that should result in a slightly reduced range of motion, but we've still got plenty of motion right in there to do what we need to do. It doesn't crank back quite as far anymore, and we've got more torque, so that arm is starting to look pretty good in there. And if we wanted to get right out over to here, we might, even if we increase that a little bit, be able to increase the length of that arm. Now I'm going to leave it to you to play with your parameters and come up with the optimal design for your arm. Okay, so go ahead, play with those parameters and get everything hooked up. And then as you're doing that, we can now start going back and saying, okay, well, here we were just focused on those dots. I didn't want to start drawing the whole diagram in because sometimes you end up with some weird looking things like that. Now what you can actually do is you can come in here and we can try editing some of these up. And so for instance, if you wanted to have a more solid profile on here to show you what this was actually going to look like, we can come in here and that was our arm. So linkage arm right here. You can activate, oh, not the linkage. We just want arm to be activated. And you can come into your arm and you can come in to your sketches right here. And you can come in and you can take a look at sketch one. And now you can say, oh, okay, we've got this all sketched out right in here, and we were just using these circle profiles right here. We could come in here and we can increase those circle profiles a little bit. And so if I change this dimension right here, that was D11 plus 4. Let's change that to D11. Let's make it a little bit of a bigger circle here. Instead of having 4 millimeters all the way around, let's make it have a centimeter all the way around. Okay, and the way we set that up, those all expanded quite a bit. And now you can come in here and you can add a few lines and you can join these together. And so you can pick a spot on here, pick a spot on there. And you can fill that profile in and we can say escape, thank you, we're all good right there. And we can finish that sketch right there. And because we're still in this arm and we're looking at that arm, our timeline for that arm, you can see that we used to have this big long timeline of everything's been done. Now we're just looking at the arm right here. We can double click on the extrude for that arm, and on our profile it says there's 8 selected. Let's just add that profile in there and that and say okay. And now we've got that arm all put together as a solid piece, and that looks really great. Let's come up here and activate our entire structure. Okay, and now that's starting to look a bit more like a robot arm. There's our bucket right in there. That's working really nicely. Okay, we might want to come back in and edit that bucket to make it a little bit bigger now that we've played around with some of this. And here we go. It is starting to work pretty good. Okay, now we want to come in here and it's ceased some of our movement a little bit right here. It's made the arm grounded again. Unground that. We'll just continue. There we go. And now that's reaching out down in there. And although it shows us that that's not, there we go. We're just holding the wrong part. That can reach out, that can come down in there, that can scoop up. And when this linkage is retracted, when the syringe is all the way out, comes in right there. Well, maybe we do want a bigger bucket to move more dirt in one scoop. I'll leave that to you to play around with. You might also want to come around in here and say, well, now that we've increased the radius around those holes to 1 centimeter on each side, we want to play with the radius on these holes. We can bring them up a little bit and make them a bit bigger. And so we can do the same sort of thing. So this right here is our boom. So we can make the boom active. Click on the little button there, the boom becomes active. We can come into our sketches right here and we can edit sketch 1. And what's really nice is, again, it's simplified it down because this is the only active part. We're just looking at that right in there. And there is sketch 1. And let's come in right here. And in sketch 1, there we go. There's sketch 1. We want to change the diameter of our outside circle. We were at 15. I think they look better when we're up at 24. That comes up a little bit bigger. And let's set this outside diameter. It's at 7 right now. Let's bring that up to 24. That expands up right in there, and that's probably enough to finish that sketch. And now that looks a little bit meatier at those two ends, looking a lot nicer, less likely to break. We've got more material in there, and we can come back in here and activate our entire component. And now this is really starting to look like a nice working syringe arm. Somehow it grounded this again for me. Just unground that. And then you can get in here. You only need to have one component grounded at any one time. It's giving us a little bit of warning on some of our connections in right here, but they still seem to be rendering just fine. And we have a two-dimensional profile of a working arm that manages to meet our requirements and able to dump things out. And that's looking pretty good. Okay, so in the future, I'm going to take a look at how we can start to bring some of your control boards in here, and we can actually set it up so that you remember we made a control board a little while back. We can actually create a linkage between the control board and each of our syringes so that we can move the levers back over here just like you would when you're driving this for real, and you can examine the entire range of motion, and then we can render it out and take a look at it. But what we're going to do in our next couple of steps is actually take these profiles and then use them to actually create real three-dimensional pieces that we can cut out on the laser cutter so that we can assemble things out. What we've been doing for right now is determining what sizes and lengths are going to be optimal for our design. Because everything's parametric, you can go in there and you can tweak these. You can come back in here, and for your bucket, for instance, if you wanted a different size bucket, you can activate the bucket, come down here into your sketches for the bucket, and just as we played around with some of the other parameters on the bucket, you can come in here and you can say, I want that to be 55, not 550. Make that 55. Make this 65. Okay, and then you can see how that affects your bucket mechanism. You can also play with the location of these connections right here in your parameters, because those were parameterized. Just remember when you're all done to come back and activate the entire component, and watch out for the fact that it keeps making that arm grounded. It really, really, really wants to ground that arm. Okay, and oops, there we go. Get that bucket coming around the right way, and you may have to play with those connections right in there in order to get your bucket control working again, because that dimension between there and there does affect the ability of that linkage to move things. And you can see right now with that change that we made in the dimension, it's a little more difficult to scoop that all the way around. Oh, looks like it does come out pretty good. So that can come in and that can scoop down right into the bottom, scoop everything up. Then you'd be able to curl that in. In order to lift it up, reverse kinematics requires me to push it back in the wrong direction. But there we go. That goes in, picks up, scoops out, and you can reach out and dump that into your dump truck. Hope you get some great dimensions. Have some fun with that. And remember, if you have to go back and try something a couple of times, we've got the undo key, and every time you save it, so save frequently, every time you save it, you get a new version of it, and you can always go back to a previous version and say, okay, I'm going to start over from there again.